Okay, so up until this point we have not solved any exponential equations, and we're going to do kind of the first way of solving exponential equations today, but they all are going to have the same base. Okay, so it's not a technique that will always work, but it's a technique that will work if they have the same base. So we're going to solve. First example, 5 to the x equals 5 to the 2x minus 6. I know it's an exponential because I have a base that's a number and a variable that is an exponent. So it's an exponential equation, and they have the same base. Okay, so I could do a log base 5 of each side, and it undoes a 5 to the power on each side. So if I do log base 5, that will get rid of these 5s. So I'm left with x equals 2x minus 6. Now you don't have to show me that every time. If you look at that and the bases are the same, you can just simply set the exponents equal to each other. But that's why it works, because I could do a log base 5 of each side, and that'll get rid of both of the 5s. Now it's just a simple two-step algebra equation. We'd subtract 2x and divide by negative 1, so x equals 6. Notice if I plugged 6 back in, if I plug 6 back in, 5 to the 6, whatever that is, equals 5 to 2 times 6 is 12, minus 6 is 6. So 5 to the 6 equals 5 to the 6. It works. So x equals 6. Okay, so that's about as easy as it gets if the bases are already the same. Most of the time, you're going to have to make the bases the same. So 5 to the x plus 3 equals 1/5 x. Now these have different bases. So you need to choose what you want each base to be on each side. Well, this is 5 already. Can I write 1/5 with a base of 5? Well, the 5's on the bottom, so 1/5. If I move that 5 to the top, that becomes 5 to the negative 1. So 1/5 is 5 to the negative 1. So 5 to the x plus 3 equals 5 to the negative 1 x, or to the x. And then you can multiply those exponents, so I get 5 to the x plus 3 equals 5 to the negative x. Alright, so that's the hard part. Now you can just set the exponents equal to each other and solve. Go ahead and finish that problem. Alright, so negative 3/2. Another example, I'll let you try this one. 9 to the x equals 3 to the 6x plus 2. See if you can figure out what the base is going to be on each side. Write each side with that base, and then set the exponents equal to each other and solve. So the base we chose is 3. So right 9 is 3 squared. So it's 3 to the 2x, and now you can set the exponents equal to each other. So x equals negative 1/2. Anybody have that? Alright. Not a whole lot of us, but that's alright. That was the first one I had you just try by yourself. How about 8 to the x equals 4 to the x plus 4? Try that one. Figure out what the base is going to be. I'll give you a hint. The base is not 8 or 4. Okay, we're using 2 as our base. So we can write 8 as 2 cubed. And we can write 4 as 2 squared. And then you can multiply, so it's 2 to the 3x equals 2 to the 2x plus 8. Remember to distribute the 2 to each of them. And then set the exponents equal to each other. Alright, last problem, and I'll let you work. It's not going to have the same base, but if I have 6 to the x equals 10, and I asked you to solve this, remember we're trying to solve for x, get x by itself. By now I hope that you realize that logs and exponentials are inverses of each other. So if we're going to get rid of 6 to the power, we have to do a log base 6 of each side. And that will undo the 6 on the left side. So we have x equals the log of 10 base 6. It's basically rewriting it from exponential to log equation. Okay, log base 6. Now, we can do that on our calculator. We don't have a base 6 on our calculator. But we could change that using the change of base to be the log of 10 divided by the log of 6. And that we can do on our calculator. So we do log of 10 divided by the log of 6. So we get our answer, 1.285. Alright, so that's the new material for today on 6.6.